As promised by your math teacher, here it comes, a little information on midpoint and distance formula on a complex number plane. Right, I mentioned to you guys that I would be sharing a little bit more formal language around these two formulas with you, and then also doing an example. If you'd like, we can also do another example on Monday. I probably will do that with you just so you get a little extra practice. And then when you are finished watching this video, I want you to finish the problems on distance and midpoint formula found on the bottom of page 8. And incidentally, also go back and on number 9, you guys were doing a little bit of building functions. And I know that was a different video, but please do number 9 as well. So number 9 and number 10, I believe it is, on page 8 after watching this video. And that'll give you guys some good practice on those pieces. Okay, so the big thing, I guess, would be to notice for this formula that they are using a plus bi as a general form of your initial complex number, and then s plus ti as your second complex number. And I think I used, when I gave you guys the formula, I just said, hey, we're bringing together the real, right? The real components. So I might have even said like r sub 1 and r sub 2. But basically what you need to remember is that, and as you can see right here, in this formula, we're combining the real components for the real component of your midpoint, and then you're combining your imaginary number values so that you can get the imaginary component of your midpoint. Okay, so let's go ahead and just plot these two so you guys can kind of see them. This is going to be sort of just a rough sketch. 4 minus 3i is located here, remembering that this is our real axis and this is our imaginary axis. So 4 minus 3i, 1, 2, 3, 4, 1, 2, 3, there's 4 minus 3i, and 2 plus 2i, 1, 2, 1, 2, there's my 2 plus 2i, here's my 4 minus 3i, whoops, and it's going to be just as easy as all of this. We are going to take our real components, add them together and divide by 2. So you're averaging the real component of your complex number, and then you're averaging the imaginary coefficients here. And this is going to be in terms of I at the very end once we get our number figured out. So we will go ahead and say 3, comma, and then that looks like it's going to be a negative 1/2 I. So let's see if that looks like it'll find us the middle of our line. So here's our line, and 2 and negative 1/2 I. There it is right there, guys. You just found the midpoint on a complex plane. Okay, easy. Add together the reals, divide by 2, add together the imaginary components, divide by 2, and you'll arrive at your midpoint. Choo. Okay, next, distance formula. A little bit trickier in that we are taking the absolute value in order to eliminate the possibility of, and we're not going to include, even though we have a 2i and a 3i here and we're graphing on an imaginary plane, we are not going to use that I value in your formula. So here's your imaginary axis, here's your real axis. We'll go ahead and plot these. 1, 2, and 1, 2. There's your 2 plus 3i. And let's see, 5 and negative 2. 1, 2, 3, 4, 5, and negative 2i. So 5 minus 2i is my point right here. And I actually want to find the distance. All right, so I think that this wording should say the distance between the points, right? Maybe not the difference between the points, but maybe the distance, because this is the distance formula on a complex number plane. We are going to kind of take like the difference in our imaginary components. So we're going to figure out this distance or difference between our imaginary components, and then this distance or difference between our real components. And distance formula is based on the Pythagorean theorem, so we can just jump those numbers into their correct spots here, and we'll figure it out. So you might remember from geometry or wherever you might have learned the distance formula that you can subtract your x values and square it, and subtract your y values and square it. And the distance formula on the complex plane is kind of exactly the same, just this time we are subtracting our real components, and then we are subtracting our imaginary coefficients here. So let's see what this is going to look like with some actual numbers. I'm going to grab the real stuff here, and I'm going to say 5 minus 2 squared plus, and then I'm going to grab the imaginary stuff again starting here. So negative 2 minus 3 squared, and we'll just keep rolling with our algebra at this point in time, not to get sloppy, sorry about that. So it looks like we have 3 squared plus a negative 5 squared, and I'm just going to creep up just a little bit here so we can finish this calculation of 9 plus 25. So our distance is equal to the square root of 34. And that cannot be simplified, so that is your final distance between those two complex numbers. And let's see, that looks like it's going to be about right, about 5 point something, right? We know the difference here was 3. We know the difference here gave us a 5 by 3. So 5 point, I don't know, square root of 34. Square root of 36 is 6, so maybe 5.7. Something along those lines. That seems about right. All right, we did it. We'll have some more practice on that. Go get it. Bottom of page 8. All right, thanks guys.